Hello and welcome, friends. Today what I'm going to be introducing to you is prestressed concrete. For human being to be active, we require food, air and water. Also, for a concrete element to be durable, it requires compressive strength, tensile strength and shear strength. However, concrete is good in compression, it is fair in shear, and it is very poor in tension. In fact, the tensile strength of concrete is around 8% to 14% of its compressive strength. Imagine, you can see how low it is. On the other hand, steel is good in compression and tension. Therefore, the addition of concrete and steel will result in an element that is very good in tension, compression, and shear. So these three strengths are the required criteria for the durability of your concrete. This is why we reinforce or we pre-stress concrete with steel. So what is pre-stressing? What exactly is pre-stressing? You see, pre-stressing is the application of an initial load to a structure to enable you to counteract the stresses that will result from subsequent load during its service period. Okay? You see, in earlier days, when liquor and wines are stored in barrels, these barrels are usually bound by metal bands. You can see the metal band. Look at it. This. And this metal band will cause a huge compression on the barrel. They'll be causing compression on the barrel from outside. You can see, of course, they'll be causing compression on the barrel. So when you now open the barrel and you fill it with liquor, the liquor will try to expand to all boundaries of the barrel. Of course, that's the behavior of liquid. When you pour liquid in a container, they will try to expand to all boundary of the container, and they'll be causing compression on the internal surface of the container. It will be causing compression on the barrel from inside. So the metal band is causing a compression from outside, and the liquor is causing compression from inside. Alright? That way there will be a balance and the barrel can have a long life. So look at this. Look at this container too. It is used to store liquid, be it oil or water or any kind of liquid. But there's no band on this keg. There's nothing causing a compression from outside on this keg. So when you start filling it with liquid, and this liquid is compressing the keg from inside, the keg will have no other choice but to be compressed. That is why it usually slacks after some period of its service. Okay, so this keg is not pre-stressed, but the metal band is pre-stressed. So that is what pre-stressing is. Okay, so I said pre-stressing is the application of an initial load to a structure to enable you to counteract the stresses that will result from subsequent load during its service period. Okay, so in the case of the barrel, the initial load is what? The metal band. The metal band, that's the initial load. And what is the stresses that is resulting from the subsequent load? That is the compressive stress from the liquor. Alright? So this same concept of pre-stressing is done in concrete too. But the kind of steel we use is not a rebar, but some wire strands which have higher tensile strength, and we call them tendon. Okay, they are called tendon. For concrete reinforcement, we call them rebar, or we call them reinforcing steel. But in the case of pre-stressing, we call them tendon. So just as in reinforced concrete, the tendon is placed in the concrete to increase the strength of the concrete. That is why we use steel. Tendon is also a steel. Okay. But the tendon is tensioned. That is, we pull it, we stretch it to a particular limit. You see, for structural elements like beam and slab, pre-stressing is done in the longitudinal axis. That is the longer span, because that is where the limit states are usually maximum. Limit states like deflection, cracking, creeping, shrinkage, shear, and the likes. Okay. So when you want to pre-stress your concrete, there are 4 steps. There are 4 steps in doing that. Number 1, you first of all prepare your frame. You prepare the frame, something like a formwork, the frame in which the concrete is going to be casted and the pre-stressing is going to be done. So that's the first step. The second, you anchor the tendon at one end of the span. You pull it and clip it at the other end of the span. Number 3, cast the concrete on it. Number 4, release the clip and allow the tendon to regain its original length. Now look at it. The tendon was pulled to a particular limit. It is then released to regain its original length. Now the question is, how will it regain the original length? You tension the tendon, they want it to, then after that you now release it to regain its original length. How will you do it? Of course, by compressing itself. But since the concrete has been casted on it and they are now monolithical, the concrete will be left with no other option but to compress with the tendon, since they are now the same thing. You've casted them together. Okay? So this is how we induce a compressive stress to the concrete. Let me make an illustration of pre-stressing system with these household materials. So I'm going to make an illustration of pre-stressing with these simple household materials. Alright? So let this white elastic material represent our tendon, the tendon that we're going to use for pre-stressing the concrete. You can see it is stretching so well, and that's giving me an impression that it is very good in tension. Okay? So this black tape represents our concrete, the concrete that we're going to cast around the tendon. Alright? And this clip, they will represent the anchors that we're going to use at the two end, at the both end. This is the dead end of the frame, and this is the live end of the frame, where I will apply my load from, where I will pull the tendon from. Alright? So let's start by anchoring the tendon at the dead end. So you anchor it over there, so like this. Okay, clip it as anchored. So I've anchored it. Then after that, I will now pull it. I will stretch the tendon. I will put it in tension. I will tension it. That is the application of load. That is my initial load that I'm applying now. And then I will clip it at the live end, like this. So the next step is to cast the concrete. So like this, I'm going to cast the concrete around the tendon, like this. Okay. So right now the concrete has hardened, it has been casted, it has gained its maximum strength. So the next thing for me to do right now is to do what? Is to release the load at the live end. So after releasing, let's see what will happen. Now I'm releasing it. Done. Now take a look at the concrete. What's happening? Look at the surface. Do you see it? It is wrinkled. That's what? It is a compression, because as soon as I release the tendon tried to regain back its original length by compressing itself backward. But because the concrete has been casted with the tendon, the concrete is left with no other choice but to do what? But to compress together with the tendon. That is why we are having this wrinkled surface, telling us that this is now in compression. Alright? Originally it was smooth, but the moment I released the load at the live end and the tendon has an opportunity to compress, it's compressed together with the concrete. So by doing that, we've induced a compressive strength in the concrete, and this compressive stress is what we call pre-stressing. And this compressive stress is going to counteract the external compressive load that is coming on the structure after it has been loaded. I believe you get it with this simple explanation. Before the application of any external load, we will pre-stress the concrete to look like this. And as you know, the load coming on the concrete is usually a compressive load that will compress the concrete like this. Okay? Meanwhile, the concrete has been compressed internally. So when the external compressive load comes on it, we can now have this kind of scenario. Okay? It will now be balanced, because there is a compressive stress from inside, another compressive stress from outside. Then compressive stress will meet compressive stress, then we have a balance. Alright? However, there can be deflection or cracking if the external compressive stress is greater than the induced compressive stress. Alright? But if the induced compressive stress is greater than the external, there will be no deflection. Okay? So reinforcing is a way of increasing the strength of the concrete, but pre-stressing is a better way of doing that. Okay? So there are two types of pre-stressing. One, we have pre-tensioning, and two, we have post-tensioning. Both pre-tensioning and post-tensioning are still pre-stressing. You see, for pre-tensioning, the tendon is first tensioned. Then you cast the concrete around it. The tendon is then released to compress, and this compression will be transferred to the concrete as well. As it sounds, pre-tension. That is before. It means you tension the tendon before you cast the concrete. Okay? And for post-tensioning, you first of all cast the concrete, and after the concrete has been casted and it has gained its maximum strength, you will then tension the tendon. Okay? So if you look at the meaning, post-tensioning, it means you tension the tendon after you've casted the concrete. Pre means before, post means after. There are two types of post-tensioning. We have bounded post-tensioning and we have unbounded post-tensioning. Bounded post-tensioning is when the tendons are placed in the conduit. Place it in the conduit majorly to avoid corrosion. Okay? And for unbounded, this is when the tendons are not placed in a conduit. So instead of the conduit, we use grease. The application of grease will also reduce corrosion, because the contact of the tendon and the concrete is what brings corrosion. You understand? But when there is a medium between the concrete and the steel or the tendon, there will be no corrosion. So if you put a conduit in between, it will avoid corrosion. If you add grease, it will avoid corrosion. So in the case of bounded, we use conduit, and in the case of unbounded, we use grease. Pretension is used for precast elements, smaller elements. This way you can just pre-stress that element in a convenient environment and then you bring it to the site for installation. Pre-stressing is better done that way. But for in situ elements, cast in situ, like bridges, post-tensioning is the appropriate and easiest method. You don't apply pre-tension that way, because post-tensioning will give room for adjustment. But adjustment is difficult in pre-tensioning. Okay? So this is all I've got for today, and don't forget to like and make a comment to my video. I welcome your question as well. Yeah, you can bring it on. And most importantly, please subscribe to my YouTube channel to see more of my tutorial videos.